Hey guys, so we've been talking about conic sections for quite a while now. The last conic that we're going to talk about is the hyperbola. It's kind of the weirdest one. It's almost like two parabolas facing away from each other, but it's not the exact same shape as a parabola. So just so you can get a quick review of what all the conics are. Okay, the way that they're formed is actually by slicing up all the different ways possible two cones that are back to back to each other. Okay, so see how these cones, these mirror imaged cones are right here. Right, if you slice them perfectly across side to side, right, you're going to get a circle. Right, if you slant that a little bit, but still slice it across, you're going to get the ellipse that we just talked about. Right, if you cut it in a parallel line to the shape of the cone, okay, you're going to get a parabola. And this last one is if you cut up and down, but it's not parallel, right? So it's going to actually hit your cone twice, then you're going to create a hyperbola, okay, which is like two parabolas facing away from each other, right? There's two examples right here. Okay, so a parabola is just the set of all points such that the difference of the distances from each point to the foci is a given constant. So it's the exact same definition as the ellipse, right? But we're talking about the difference between the distances instead of the sum, like we did with the ellipse. All right, it's tough to visualize, so we should probably just pop right into the examples. Okay, so we have to be able to deal with these two strands of equations. Ooh, turn. Good. Okay, so these two strands, just like everything else that we've done so far, right? One of them is going to be open out side to side, and one's going to open up and down. Okay, so this one's going to be side to side. This one's going to be up and down. Things to notice here: x squared comes first for the side to side. Y squared comes first for the up and down. Right? That's also going to tell us our intercepts, right? So instead of having four intercepts, two x-intercepts and two y-intercepts like we did with the ellipse and the circle, right? This one we've only got intercepts on the axis of the variable that comes first. So the first one, the side-to-side one's only going to have x-intercepts, and the up and down one is only going to have y-intercepts, okay? So that's one thing to notice. Another thing to notice is the a and the b stay put, right? They're not switching. There's no like A has to be bigger than B or anything like that, like there was with the ellipse. They're obviously subtracting in between, right? So this is the only one that is subtracting, so that's good to remember. And lastly, you're always going to be equal to 1. So we're going to be dividing both sides by a constant to get 1 on the right side of our equation, just like always. Okay, so to get started, we've got the center is at 0, 0 again, which is nice and lucky for us. We've got a nice little center, so that way we don't have to worry about translating it with an h and a k, just like we did with the ellipse. Okay, the intercepts are going to be at the a's. Okay, so in order to find the intercepts, you take the square root of the constant that's underneath whatever that first term is, the positive term. Okay, which is an x-intercept for the x's. So I can pick an a over here, and negative a has to be obviously the same distance on the other side. Okay, the other one, we're going to have a and negative a on the y-axis because that is under the y. Alright, you're going to have foci again. Right, these foci are again going to be on the same exact axis as your a's, right, as the long axis. Now the foci for hyperbola are actually on the outside of the graph instead of on the inside, meaning they're actually farther away from the origin than your a's are. So our foci can be like out here, C and negative C. They're once again C and negative C. And those are the points that are used to tell us. Oh, that one's a little bit too far away. All right, that's how we are calculating the curve. Okay, it's from the foci. Now notice that there's no b in here. There actually is a b if you take the square root of the other constant, the other constant underneath the y or the x term. It actually is going to exist on here, and it's only going to help to give us the slope of our asymptotes. Okay, so that's the role of b. In this case, we've got b and negative b. Right, but they're not actually part of the graphs. You never have to graph them. You can only graph them if you'd like to. If you want to graph them, it's totally fine, but you never have to. All right, one other last thing to notice is that our relationship between a, b, and c goes back to the same as the Pythagorean theorem. Okay, so a squared plus b squared equals c squared. Notice the reason why is because the c is farthest away from your origin. Okay, it's the biggest distance. All right, now the asymptotes. All right, so the asymptotes are for the x graph, right, the one that opens side to side, it's plus or minus y equals plus or minus b over ax. Right, what that means is that in order to get the asymptotes, in order to draw our asymptotes, all we do is these two direct variation equations that go through the origin. All right, you go up b, that's the benefit of b, and over a, or down b, left a, and that's going to create our lines, our imaginary lines that our graph can't cross. Now that one's good, that's plus b over a, and we can also do the negative graph to draw the other one. Okay, so these give us basically the curve, the shape of our graph. So then to finish our graph, all we're going to do is you're always going to start with A, and you're going to go to the side towards your asymptotes without crossing them. And that's it. We can do the exact same thing for the other graph, right? Except notice the asymptote changes to A over B, right? Because the slope is going to change. So we change the slope to A over B. There's one asymptote, negative a over b. It'll look like this. Okay, because you're going up a over b, right, or down and over. And we can finish our graph by starting at a and going towards the asymptote. All right. So we'll dive into some examples. So first thing we're going to try to do is we're going to find the intercepts, asymptotes, and the foci of this hyperbola. Okay, so you might need to look up above to get the information that you need to figure out which graph we're using, right? It's the x squared one, so we're using the one on the left, the strand on the left. So we need to find the asymptotes, the intercepts, and the foci. Now, the intercepts we know right away because the x comes first that it's x-intercepts. So we know that it's their x-intercepts, and the x-intercepts are just the plus or minus square root of the constant below it, which is plus or minus 3. Right, now from there, the foci, right, in order to calculate the foci, we need to use our equation, a squared plus b squared equals c squared. Okay, so we've got a squared and b squared. So c squared is 13. So we know that this is plus or minus root 13, 0. And same as with the ellipses, right? Because it's an x-intercept, right? We know that the foci is on the x side and the y is at 0. And lastly, to find the asymptotes, right? It's y equals plus or minus some slope x, right? It's two different equations of lines. Now it's b over a for this one. If we see right here, it's b over a. B is 2 because the square root of the constant under y, and the a is 3, so it's plus or minus 2/3 x. So that's all the information we need. The second problem is very, very similar. Right, we have to do a little manipulation, then we're going to use the other type of graph. Right, so this is going to be y squared over 4 minus x squared over 1 equals 1. We divide everything by 4 to manipulate the graph. Now because the y comes first, we know we've got y-intercepts. So the y-intercepts are plus or minus the square root of that constant underneath, which is 2. The foci, we need to use our a squared plus b squared equals c squared. We've got a squared, b squared, so c squared is 5. So it's going to be plus or minus root 5. Now remember that the plus or minus root 5 is on the y part of our coordinate because it's a y-intercept. And lastly, the asymptotes. All right, for this strand, we've got y equals plus or minus some slope, x. All right, the slope for this is a over b, not b over a. Okay, so a is 2, b is 1, so it's plus or minus 2x. All right, remember that this is a squared, and this is b squared, always. Right, so that's going to be really important because you're going to use that in all these problems. Now we're going to take that and do it again a couple more times, but also graph when we finish. All right, so for this one, we've got to graph this hyperbola. It's already in a good place for us. X comes first, and we know we've got x-intercepts. The x-intercepts are plus or minus 8. The foci, right, are going to be on the x side of the coordinate, so we know it's comma 0. And the x, remember we've got a squared is 64, b squared is 36, Add those up, take square root, you're going to get plus or minus 10. Okay, those are the foci. And the asymptotes are y equals plus or minus some slope x. Now if you look at your notes from above, from the last page, you know that it's b over a. Okay, b comes from this, a comes from this. Okay, so the square root of 36 is 6, square root of 64 is 8, so plus or minus 6 over 8, which reduces to 3/4. So there's all the information we need. Now we can use that information to draw our graph real quick. Now, we probably want to scale these by 2s, because 2, 4, 6, 8, 10. Okay, so I'll just draw them like that, so you can scale it by 2s. You don't have to do that, however you want to do it. It works for me. But we got to draw our x-intercepts on here, so we've got over at 8 and negative 8. So we've got 8 and negative 8. Okay, our foci are at plus or minus 10, 0, so just 2 more coming out there. And our asymptotes here are plus or minus 3/4 x. Okay, so that means you can go up 3 over 4, and you're going to get this here. It's always coming from the origin. Plus 3 over 4 again. Right, and you've got a good idea for a graph. Okay, that's the positive one. We got to do the negative one also. Down 3 over 4, or up 3, left 4. And we again have our second asymptote. Now these asymptotes are really important because what the asymptotes do is they give us basically where the shape of our graph. Okay, so our graph starts with A and negative A. Right, make sure you're starting at A and not C. And they go towards the asymptotes in a curved nature like that. Okay? Now the next one. We have to divide by 144 and move the 9 over. So the manipulated equation is going to be x squared over 9 minus y squared over 16 equals 1. Okay, now since the x comes first, we know we've got x-intercept. It's going to be plus or minus 3. Foci. Ours comes from C, right? It's going to be on the x1, so the 0 is with the y. In order to get that, we got a squared, which is 9, b squared is 16, add them up, take square root, you get plus or minus 5. Right, and the asymptotes are y equals plus or minus b over ax. B is 4, a is 3, so it's 4/3. Okay, so what we're looking at here is we've got the x-intercepts are 3 and negative 3. Foci out at 5 and negative 5. And the asymptotes are plus or minus 4/3 x. So I got to go up 4 over 3, down 4, left 3. There's one asymptote. The other one, the negative 1, up 4, left 3. And down 4, right 3. Alright, so that's close enough. And I start at A and I go towards the asymptotes. That's the general idea of it. And the last one, okay, we're going to manipulate this equation. And what we're going to get here is y squared over 9 minus x squared over 1 equals 1. Alright, since y squared comes first, we've got y-intercepts at plus or minus 3 again. Our foci are going to be at 0, plus or minus root 10, right? A squared plus b squared equals c squared. And the asymptotes are going to be y equals plus or minus a over b x. A is 3, right? The square root of 9. And b is 1, so 3x. Okay, so this one, we've got our plus or minus 3. 10 is just going to be on the outside of that. I'm not going to be able to fit it in there, but hopefully you can. It's just going to blend too much. All right, now my asymptotes are up 3 over 1. Okay, so my asymptotes are going to be real steep. And what that means is I'm going to have a really narrow curve. Okay, so we got our asymptotes. And to finish these up, they're going to go from A towards the asymptotes. That's real pretty. All right, and that's good. That's finished right there.